This is section 2.5, Introduction to 2.5, part 2, and we're going to talk about going through and doing some geometric proofs. Now, we've done lots of equations proofs and dealt with the basic properties, but now we're going to dive into looking at some geometric proofs. Now, one thing that's going to be very helpful for you, you need to make sure that as you're looking at this and as I'm going through this, that you have your tool belt with you and you're able to look at your tool belt, because there are going to be some things on here that we're going to look for that are on your tool belt that we've went through together in class. Okay, so let's take a look here at the first proof, and you'll notice on both of these proofs, quickly before I zoom in on one, that both of these proofs, the statements have been provided for you. To begin, to kind of get started, alright, to get started on these first couple sections, they're going to give you most of the statements. They may have you fill in a statement or two, but they're going to give you most of the statements, okay? And as we go along, then eventually you're going to have to be able to start making up the statements on your own, okay? So let's take a look here at this first proof. Alright, writing a two-column proof here, it says in the given that the measure of angle 1 is equal to the measure of angle 3. So the very first thing you're going to do, again, on these is you're going to go down here to that first statement. You notice measure of angle 1 is equal to measure of angle 3. That's reason is going to be that they're given. They gave that to you. And you'll notice in the picture, if you look here at the picture, okay, they've got these marked. 1 and 3 are congruent. Okay. All right, so now what we have to figure out here is where they're coming up with these statements and what's the reason that they're coming up with them. So the first statement says the measure of angle AEC is equal to the measure of angle 1 plus the measure of angle 2. Well, I'm going to go up and outline for you AEC, and AEC is right here. We go from A to E to C. And what they're saying is that the measure of angle 1 plus the measure of angle 2 is equal to AEC. So as you look at this, you'll notice we have a part plus part equals whole. Well, if you look at your tool belt, where we see part plus part equals whole, we're talking about the angle addition postulate. Okay? So as you're looking at your tool belt, we're going to write our reason that they're able to say that is because of the angle addition postulate. So we're going to put that here, angle addition postulate. Okay, and I'm going to finagle this here like so. So that's our reason for step 2. Okay? All right, now, as I look at the picture again, it says here in step 3 that angle DEB, the measure of angle DEB is the measure of angle 2 plus the measure of angle 3. So again, I'm going to go up and I'm going to outline DEB. So DEB comes along here and goes right here. And you'll notice they're saying that angle 2 plus angle 3 is DEB. Well, this happens to be the exact same thing. You're using part plus part equals whole in the picture. So we're going to use the angle addition postulate. So that's going to be our reason for step 3. Again, you're using the same thing, angle addition postulate. Okay? Now, the next step says the measure of angle DEB is now equal to the measure of angle 2 plus the measure of angle 1. Now, sometimes you're going to have to look at the steps before to figure out your reasons. Okay? Now, if you look up here, we started here where we said the measure of angle 1 is equal to the measure. So 1 and 3 are equal. Okay? And you'll notice that they have a 1 and 3, and you'll know if we say 1 and 3 are equal, we can interchange them. We can put 3 in for 1, we can put 1 in for 3. Well, if you look at the line before, AEC is 1 plus 2. DEB is 2 plus 3. What they've done from this step right here, DEB equals 2 plus 3, to DEB equals 2 plus 1 is they've interchanged these two right here. These two have switched. They've substituted it in. So this is the substitution property. Okay, that's the substitution property for that reason. They've replaced the 3 with the 1. Okay, now you'll notice again we go from this line right here, DEB is equal to the measure of angle 1 plus the measure of angle 2, or 2 plus 1, to now AEC and DEC, or DEB, are now equal. And if you look, and I'll outline this, if you look at these two right here, it says DEB is 1 plus 2, and AEC is 1 plus 2. Well, if they're both equal to the same thing, okay, if they're both equal to the same thing, if they're both equal to 1 plus 2, then they're both equal to each other, okay? Which means in this case, we're using the transitive property. We've got 3 things that are equal to each other. Or I'm sorry, not the transitive property. Let's cross that out. We're going to use substitution property because we said AEC is 1 plus 2, so I'm replacing 1 plus 2 with AEC. So we're going to use this as the substitution property. So we'll go substitution. And now we've filled out the very first geometric proof. Okay, so we've been able to fill out this first geometric proof. All right, now let's take a look here at the second one. This one's a little bit longer and is a little bit more challenging. Okay, so in the given, you'll notice it says AB is congruent to CD. So we notice there we've got this guy right here. This is going to be given. First reason given. Okay. Now, this is one thing we haven't talked about yet, and we're going to talk about this in class when you guys come in. And this is where we talk about in your tool belt. If you'll look and see, we have the on the second page the definition of congruent segments and the definition of congruent angles. Okay. That's what we're talking about here, and we're going to talk about that on class on Monday. So for your definition for right now, just put this in, and we're going to discuss this in class. The definition of congruent, and we're talking about segments in here, so we're going to call that definition of congruent segments. We're going to put that in there as our reason. And I'll explain why. We go from a congruent symbol to an equal sign, essentially, is what we do. Or you go from equal to congruent. It's always going to be that way. Okay, and we'll discuss that more in class as we come in. Okay, now, next one here says AC is equal to AB plus AC. And this should be a B. This guy right here, we're going to cross this out. This is a mix-up. That should be a B. AB plus BC. Okay? All right, so as we look at the picture here, it's saying that if we take AC is from here to here. If we take AB and we add BC to it, it's going to be AC. Or in other words, part plus part equals whole. Okay, so this, in this case, is the segment addition postulate. Okay, that's the segment addition postulate. Now, the next line says BD is equal to BC plus CD. Well, if I take BC, here's BD right there. If I take BC and I add CD to it, again, part plus part equals whole. So we're going to do essentially the same thing. So we've got the segment addition postulate. Okay, segment addition postulate. Okay, now, as we look at the next step, it says BD is equal to BC plus AB. Well, this is similar to the previous one. If you'll notice, again, these two have changed. Okay, from this line to this line, the AB and the CD have replaced each other. Well, up here we said AB is equal to CD, so we can put one in for the other. So again, this is going to be the substitution. This is going to be the substitution property right here. This is the substitution property. Okay? And then the last one down here, now, as we look here, we said that BD is BC plus AB. Well, if you notice, this line right here and this line right here, even though they're changed spots, they're the same exact thing. And you'll notice that we replaced BC plus AB with AC. These two are the same. The BDs are the same. But we replaced it. So this again is the substitution property. I'm replacing, if I said something equals something up top and I replace it later with the same thing, that's substituting. Okay? And then the final step, again, we'll talk about this in class, but we go from an equal sign to a congruent symbol. We say AC is equal to BD, and then AC is congruent to BD. That is the definition of congruent segments. Okay, that's the definition of congruent segments here. And let's see here. We're just going to write this in. This is definition of congruent segments. Okay, so we've done two proofs. All right, we've done two proofs, and it'll be a quick WSQ because there won't be a lot to ask in these because we went through these pretty quick. Okay, be a quick WSQ. Make sure you complete that WSQ, and this concludes section 2.5, part 2.